this video, I will discuss on Math 9 Module Quarter 2, Week number 4. So week number 4 is about rational exponent and radical expressions. Your previous lesson is all about integral and zero exponents. This time your lesson is on rational exponents and radical numbers. When simplifying expressions with rational exponents, you should remember the laws of integral exponents. The rule is the same. However, you need to remember the rules in adding fractions. In adding fractions, you can only add fractions if they are similar. Otherwise, you change dissimilar fraction to similar fraction. So let's have examples here. Simplify the following expressions. Number 1, a to the power of 1 half times a to the power of 3 halves. So in here, they have the same base, a. So what we're going to do is we're going to copy the base a, then add the exponents. Now the exponents here are 1 half and 3 halves. So if we're going to look at the denominator, they are the same, 2. So it means that they are similar. So we can simply add the fractions. 1 half plus 3 halves. So 1 half plus 3 halves, that will be 4 halves. So the result is a to the power of 4 halves. Then 4 divided by 2, that is 2. So our answer here should be a squared. Number 2, 6x raised to the power of 6 raised to the power of 1/3. So applying power of a power, so we're going to multiply 6 and 1/3, the exponents. 6 times 1/3, that will be 6 over 3. Then 6 divided by 3 is 2. So our resulting expression should be 6x squared. Then 6 squared, that will be 36, and x squared. So the answer is 36x squared. So this one applies power of a product. Number 3, 4 over 9 raised to the power of 1 half. So applying quotient of a power, so we're going to raise the numerator and denominator to the same power, which is 1 half. So we're going to raise 4 to the power of 1 half and 9 to the power of 1 half. So 4 here, we can express 4 as 2 squared. And 9, we can express this one as 3 squared. So in here, applying power of a power, so we're going to multiply the exponent of the numerator, which is 2, and 1 half. The same with the denominator. So 2 to the power of 1 half, or 2 times 1. So 2 times 1 half is 1. So we can have 2 to the power of 1. Then 2 times 1 half for the denominator, that will be, it's still the same, 1. So 3 to the power of 1 is 3. So our answer should be 2 over 3. Number 4, 12 raised to the power of 2/3 times 12 raised to the power of 1 half. So applying product of powers, we're going to copy the base 12. Then we're going to add the exponents, 2/3 plus 1 half. Now since the exponents are fractions and they are dissimilar, so first we're going to make the two similar. So our LCD here for 2/3 and 1 half is 6. So 6 divided by 3 is 2. 2 times 2 is 4. So 2/3 will now become 4 over 6. Then for 1 half, LCD same 6. 6 divided by the denominator 2 is 3 times 1, that will be 3. So 1 half is equivalent to 3 over 6. Okay? Then they are now similar fractions. So copy the denominator 6 and add the numerators. 4 plus 3, that will be 7. So our resulting expression here is 12 raised to the power of 7 over 6. Then in here we can express 12 raised to the power of 7 over 6 as quantity of 12 to the power of 6 times 12 raised to the power of 1 over 6. So they are just the same. Okay? So multiplying 12 to the power of 6 raised to the power of 1 6, that will be 12 raised to the power of 6 over 6. Then the second one is 12 raised to the power of 1 over 6. Okay, then 6 divided by 6 is 1, so first will be 12 to the power of 1, which is 12. Then 12 times 12 raised to the power of 1 over 6. So in here we simplify by applying laws of exponents. Then exponential expressions with rational exponents can be expressed into radical expressions. So this is the reverse. Radicals. An exponential number whose exponent is a rational number can be expressed as radicals. So in here we have the expression 8 raised to the power of 1/3. So 8 here is the base, 1/3 is the exponent. Okay. Then for radicals, cube root of 8. So the index here is 3. Then the radical sign is 1. Then the radicand is 8. So the denominator of the rational exponent becomes the index of the radical number. So in here, this is the denominator 3. So this will become the index 3. Okay. Then the base will become the radicand, and the numerator of the exponent will be the power here, in here, 8 to the power of 1. Okay, it's 1. So in the example above, 8 to the power of 1/3 is the same as cube root of 8. So to make it clear, let's have another example. The exponential expression is 12 raised to the power of 3/2. So automatically the base 12 will be the radicand in here. The numerator 3, this will be the exponent here in 12 cube, and the denominator will be the index. So since the index here is 2, we can just simply write this one, square root of 12 cube. Okay, this is read as the square root of 12 raised to the third power, or square root of 12 cube. So again, if the index is 2, you can just simply write the radical sign. The exponential number a raised to the power of m over n, when changed to radical, will become nth root of a raised to the power of m, or nth root of a raised to m. The nth root of a number is a number that is taken n times as a factor of the radicand a. You can express exponential expression to radical expression and vice versa. Examples: change 5 raised to the power of 1/4 to radical expression. So 5 here will be the base, and in a radical expression, this is the radicand. Then the denominator will be the index. Denominator is 4. So in here you have the index 4. And the numerator here, 1. So this is the exponent of the radicand. Now since the numerator is 1, so you can just have it as 5. 5 to the power of 1 is just the same as 5. So expressing 5 to the power of 1/4 to radical expression is 4th root of 5. Number 2, write 4 raised to the power of 3 halves in radical expression. So the base here is 4, so this is the radicand, 4. Then the denominator is 2, so this is the index. Now, since the index is 2, so you may not write 2, so you can just have square root of 4. Now, since the numerator is 3, so this is 3 here, the exponent of 4, supposedly. So, we're going to have your answer as square root of 4 cubed, or square root of 4 raised to the third power. Or another way of writing this one is you can just write square root of 4 cubed. They are just the same. So square root of 4 cubed is the same as this one. Then number 3, write cube root of 8 raised to the power 4 in exponential form. So radicand here is 8. So our base for our exponential expression should be 8. Index is 3, so the denominator is 3 here. Then the exponent here is 4, so this will be our numerator 4. So the expression will be 8 raised to the power of 4 thirds. Then let's have number 4, but in here this is number 5. So supposedly this is 4. So change the expression 5th root of 32 to exponential form. So in here, the radicand is 32, so this will be our base in here. Then the index is 5, so this will be our denominator, 5. Then this is 32 here, so this is raised to the power of 1, so our numerator will be 1. So our answer should be 32 raised to the power of 1/5. Next is laws of radicals. Laws of radicals are similar to the laws of integral exponents. Let a, b, m, n as integers. So number 1, nth root of a raised to the power of n is equal to a to the power of 1 over n raised to the power of n. And this is equal to a to the power of n over n, which is equal to a. So in here, the nth root of a raised to the power of n is equal to a. Okay? So for this law, it means that if the index is the same with the exponent, the answer is just the radicand, a. Number 2, nth root of a times nth root of b equals a to the power of 1 over n times b to the power of 1 over n equals a times b raised to the power of 1/2, and this is equal to nth root of a times b. So simply you can have nth root of a times nth root of b as nth root of a times b. So you can just multiply the radicand. Number 3, nth root of a over nth root of b equals a to the power of 1 over n over b to the power of 1 over n, and this is equal to a over b raised to the power of 1 over n. Then this one, you can have this one as nth root of a over b. Then 4, nth root of mth root of a is equal to mth root of a to the power of 1 over n, and this is also equal to a to the power of 1 over n raised to the power of 1 over m, also equal to a to the power of 1 over m times n, and this is equal to n times mth root of a. So let's have examples here. Apply the laws of radicals. Number 1, cube root of 12 cube. Okay. Since the index is 3 and the exponent is 3, so we can apply law number 1. So automatically this is equal to the radicand itself. So cube root of 12 cube, applying law number 1, that is equal to 12. Number 2, fifth root of 4 times fifth root of 8. So applying law of radical number 2, we can just combine the 2. So they are just the same index. So we're going to have fifth root of the radicand 4 and 8. So 4 times 8. Then fifth root of 4 times 8 is 32. So fifth root of 32. Then the fifth root of 32 is 2. Number 3, square root of 18 over square root of 2. So they are just the same index 2. So we can just combine the 2. So we can have that one as 18 or square root of 18 over 2. So 18 over 2 is 9. So square root of 9 is 3. Number 4, cube root of square root of 64. So square root of 64 is 8 in here. So square root of 64, 8. So we can have the expression as cube root of 8. Then cube root of 8 is 2. 2 times 2 times 2 is 8. Number 5, cube root of 12 squared times square root of 12. So cube root of 12 squared, we can express this one as exponential expression, 12 raised to the power of 2/3. 12 square root of 12, we can express that one as 12 to the power of 1/2. Okay. Then multiplying this one, applying power or product of powers. So we can just copy the base 12, then add exponents 2/3 and 1/2. So 2/3 plus 1/2. Then making the two similar fractions, 2/3 and 1/2, LCD is 6. 6 divided by 3 is 2. 2 times 2 is 4. Then 6 divided by 2 is 3 times 1. That will be 3. So 4 plus 3 over 6. Then 12 to the power of 7, we can express this one as 12 to the power of 6 times 12 in here. So our expression here is 6th root of 12 to the power of 6 times 12. Then applying law of radical number 2. So we can have 6th root of 12 over to the power of 6 times 12 as 6th root of 12 to the power of 6 times 6th root of 12. Then applying law number 1 for 6th root of 12 to the power of 6, this is equal to 12. Okay, then times 6th root of 12. So that will be our answer. So let's have learning task 1. Use the laws of rational exponent to simplify. Okay, so I will just have number 1 as an example here. So number 1 is n to the power of 4 raised to the power of 3 halves. So applying power of a power. So we're going to multiply the exponents 4 and 3 halves. So 4 times 3 halves, that will be 4 times 3, 12 over 2. So this is n to the power of 12 over 2. Then 12 divided by 2 is 6. So the answer here will be n to the power of 6. So kindly do numbers 2 to 5. Then learning task number 2, A. Change exponential expression to radical expression. So again, we're going to have number 1 as an example. 125 raised to the power of 2/3. So the base here is 125, so this will be our radicand. So we're going to first write the radical sign, then the base is 125. Okay. Then our denominator here is 3. So this will be our index. So we're going to put here 3. Okay. So cube root of 125. Then the exponent here is 2. So we can have this one as cube root of 125 squared. Or another way of writing this one is we can have cube root of 125 squared. So they are just same. Then for letter B, write each expression in exponential form. So let's have number 1. Cube root of 7 raised to the power of 5. So our radicand here is 7. So this will be our base, 7. Index is 3. So our denominator for our exponential expression is 3. Then exponent here is 5. So this will be our numerator, 5. So cube root of 7 raised to the power of 5 is the same as 7 raised to the power of 5 over 3. Learning task 3. A. State the laws of vertical exponents and give examples. So this is just an application of what you have learned in the discussion a while ago. Then letter B. Apply the laws of rational exponents in simplifying the expression. So let's have example number 1 here. M to the power of 1/2 times n to the power of 2/3 over m to the power of 2/5 times n to the power of 3/4 raised to the power of 6. So this is raised to the power of 6. So we're going to have the numerator and denominator raised to the power of 6. So we can have this one as m raised to the power of 1/2 times 6. This is applying power of a power. Then this is times n to the power of 2/3 times 6 over m to the power of 2/5 times 6 times n to the power of 3/4 times 6. Okay. Then for m to the power of 1/2 times 6, so this is m. Then 1/2 times 6 is 6 over 2, which is 3. So this is m cubed. Then times n. Then 6 times 2/3. This will be 6 times 2, 12 divided by 3 is 4. So n to the power of 4 over. For the denominator, this is m. Then 6 times 2 is 12 divided by 5. So this is 12 over 5 times n. Then 6 times 3, that will be 18 over 4. Then simplifying that one, that will be 9/2. Then applying quotient of powers. So we're going to have m. Then the numerator. Then the exponent of the numerator is 3. So 3 minus 12 over 5 times n to the power of 4 minus 9/2 for the denominator. Then our answer should be m. So 3 minus 12 over 5. So we can express 3 as denominator 5. So that will be 15 over 5. Okay. So this one, 15 over 5 minus 12 over 5, that will be 3 over 5. So m to the power of 3 over 5 times n. Then 4, we can express 4 as denominator 2. So that will be 8 divided by 2. So we're going to have 8 over 2 minus 9 over 2. And the answer will be n to the power of negative 1 half. Okay. Then this is a negative exponent. So we can have that one as m to the power of 3 over 5 over n to the power of 1 half. Or another way of solving this one is we can combine first the numerator and denominator. So we can just have this one as m to the power of 1 half minus 2/5, then times n to the power of 2/3 minus 3/4 raised to the power of 6. Okay, then making the two the same fractions, so we're going to have m, then 1 half minus 2/5. LCD here is 10. So 10 divided by 2 is 5. 5 times 1 is 5. 10 divided by 5 is 2 times 2, 4. So this is 5 minus 4. Then times n. Then LCD here is 12. So we're going to have 12. Then 12 divided by 3 is 4 times 2, 8. Then 12 divided by 4 is 3. Times 3 is 9. So minus 9. Raised to the power of 6. So we can have this one as 5 minus 4 is 1. So m to the power of 1 over 10. Then this is n to the power of 8 minus 9 is negative 1. The power of negative 1 over 12 raised to the power of 6. Then next is we're going to raise both the factors to the power of 6. So we're going to have m to the power of 6 over 10. So 1 over 10 times 6 is multiply. 1 over 10 times 6 is 6 over 10. Then times n to the power of negative 1 over 12 times 6 is negative 6 over 12. Okay. Then 6 over 10, simplifying that one, that will be divisible by 2. So this is 3/5 times n to the power of, then this is divisible by 6. So negative 6 over 12. Simplifying that one, that will be negative 1 half. Then since this is a negative exponent, simplifying that one, we'll just put this one in the denominator. So our answer should be m to the power of 3/5 over n to the power of 1 half. So kindly do on numbers 2 to 10. So that's it for this video. Thank you for watching and see you next time.